Okay, all right, so today we are back for Unit 1, Lesson 3, and it is to solve word problems with the greatest common factor and the least common multiple. Okay, so I think the best way to do this is just to do 4 examples together. And hopefully in that way you could just get some practice. Okay, so let's take a look at the first problem. And I'll read. Lee is sewing vests using 16 green buttons and 24 blue buttons. All the vests are identical and all have both green and blue buttons. What are the possible numbers of vests Lee can make? What is the greatest number of vests Lee can make? So here's the keyword, right? I mean, this is a clear giveaway. Greatest. And given what we've learned so far with GCF and LCM, I think you can pretty much tell where we're leaning towards, right? So this is a word problem with greatest common factor. Now, I mean, this is also made more simple by the fact that you're really only gonna have one or the other for a word problem right now in 6th grade, right? It's either GCF or LCM, so it's one or the other. So what do we need to do? Well, we need to list out the factors of 16, okay? So we got 1. Now I'm gonna write like this, only because sometimes we just don't know how many factors there are for each of these numbers until we write it out. So 2 times 8. All right, how about 3? Nope, how about 4? Yep, 4 times 4. So I'm just gonna list 4 once. I'm not gonna even list 4 twice. Okay, what else? 5, nope. 6, nope. 7, nope. 8 is 2, so we got that already. All right, so let's do it for the factors of 24, which is 1 and 24. Right, so 2 and what? That's right, 2 and 12. 3 and what? Yep, 3 times 8, actually. And then 4 times 6. So that's a lot. All right, now having done that in class, can you identify between 16 and 24, what is the greatest common factor? In other words, what's the factor list of factors that they both share? So is it 1? Is it 2? Is it 4? Or is it 8? That is the largest. So what's the largest factors they share? Well, it's 8. So the greatest common factor here is 8. Now, here's the problem. Does that answer the question? So how many number of vests that Lee can make? All right. So here you have 16 buttons and you have 24 blue buttons. Right, so 16 buttons, 24 blue buttons. All right, what's the greatest number of vests? Oh, what are the possible? Oh, let's answer this first. Let's answer this first. Okay, what are the possible vests that Lee can make? Well, he could make 1 vest, right? Now, if he makes 1 vest, it's gonna be a really weird looking vest because it's gonna have 16 green buttons and 24 blue buttons. And as far as I'm concerned, like, I've never seen someone with a vest, let alone a sweater, right? That has what, 40 buttons on it, right? So 2, right? He could make 2 vests, right? If he makes 2 vests, what can he do? Right, he could make 8 green buttons, and then 12 blue buttons, right? He could also do 4. Right, so on and so forth. So here we got 8. 8 is the greatest amount of vests No, greatest amount of S that he can make. Now, so that would be the final answer. Okay? All right, so let's move on to the next question. By the way, I realize it's also a good idea to not erase it during the video, only because even that alone adds a little bit of time. Okay? All right, examples 2. I'll read. Today, both the soccer team and the basketball team had games. The soccer team plays every 3 days, and the basketball team plays every 5 days. When will both teams have games on the same day again? All right, so here's what I'm gonna do. I'm gonna use 2 different colors. So I'm gonna use green for soccer and blue for basketball. All right, so what are the keywords here? Okay, every 3 days and every 5 days. So the keyword here is every 3 days, and the other one is every 5 days, right? So, and then they want the same day. So basically the question is something like, if you were to start at 3 days and then every 5 days, when will they meet again? So when will they have something in common, right? So that would suggest that this is a least common multiple question, because the every 3 days, every 5 days suggests that it's some sort of multiple of the original. So in this case, we have a multiple of 3, and in the other case, we have a multiple of 5, all right? So for practice sake, we're gonna set up a table, okay, just to demonstrate this to you. So I'm gonna use green for soccer, all right? And then I'm going to use blue for basketball. So, all right, they play once already, so let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, right? That's soccer every 3 days. Now, basketball haven't played the first time, which is here, all right? So don't register in this box right here, where the red is, okay? Because it starts the day before that. So it's every 5 days. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So when is the next time that you will have an SMB? So imagine if the SMB, right, soccer and basketball happened the day before the grid started. When's the next time? Right here. Is the 15th day. So think about it like this, right? If we were to do this as a least common multiple question, the question is, what's the least common multiple between 3 and 5? You do 3, 6, 9, 12, 15, 18, and for 5 would be 5, 10, 15, 20, 25, 30. So what's the smallest, right? Least smallest multiple they share. So smallest multiple they share, there we go, it's 15. So it's on the 15th day that they will meet again. Okay? All right, so let's move on. Now, okay, let me go to the laptop to do this. So here's the, before I let you try this, here's when you should use greatest common factor or what, least common multiple. Greatest common factor involves a keyword. It's always the greatest, most, words like that, right? Whereas the least common multiple tends to use like every so and so, every however many days, weeks, something like that. So in other words, it's the language of using multiples. Okay, so having said that, let's try example 1. All right, so here's what you should do right now. Pause the video, read the question, solve the question. All right, you don't have to use graphs because you're not going to set up graphs on a test, like, you know, always. So look at the question right now, press pause, and then we'll play. Okay, all right. Okay, and we're back. So let's do this then. All right, for football trials at a local school, 12 coaches and 42 players split into groups. They have the same number of coaches. What's the greatest number? There we go. Keyword. All right, so let's find the greatest common factor between what? 12 and 42. Okay. Let's see, greatest common factor between 12 and 42. So list the factors of 12. All right, 1, 12, 2, 6, 3, 4, and 4, 3, so on and so forth. All right, for 42 is 1, 42, 2, 21, 3, yep, 3 times 14. Let's see, 4, nope, 5, nope, 6, 6 times 7, 8. Okay, so what is the greatest common factor between these two numbers? Let's see, is it 1? Nope, not the greatest. 2, yeah, maybe. 3, yeah, maybe. All right, let's see, I see 6. Yep, that's it, 6. 6 is the greatest common factor. Now, does that answer the question? What's the greatest number of groups that can be formed? You can form 6 groups. How many coaches and players will be in each of these groups? Okay, so 6 groups. How would you know how many of each is in there? Well, you can divide it by 6. So if you got 12 coaches, and you divide it by 6, that means you have 2 coaches for each group, and therefore, for 42 divided by 6, you have 7 players. So each group will have 2 coaches and 7 players in each of the 6 groups. So there are all your answers right there. Okay, all right, one last one. And I think I'm gonna have to tell you that the audio quality is not that great because I accidentally left the air conditioner on. So right now I'm actually gonna turn the AC off. Okay, all right, should be better. Should be considerably better. Okay, so now, again, take a look at this question. All right, press pause, do it, and then press play and we can go over it. Okay, all right. Now, a manager at a restaurant can buy hamburger buns in packages of 8 and hamburger patties in packages of 6. Suppose the manager cannot buy part of a package. So you see the sort of language here, right? You can't break them up. What is the least number of packages of each product? There you go, least, right? LCM. So let's find the LCM between 8 and 6. So for 8 and 6, 8, right? Okay, so these are the multiples that I got so far. What about 6? Now I see a number in common, but let's see if that, so I see the 48 right there. Let's see, they are in common, but let's see if they're the lowest or the least. Let's see. Okay, I see it, all right. So 8, nope, nothing here. 16, nope. 24, there we go, bingo. Okay, so it's 24. Well, the least common multiple is 24. So the question is this though, they're asking for products. They're not asking for however many hamburger buns and hamburger patties. All right, you need 24 hamburger buns and you need 24 hamburger patties. But the question is how much of each product, right? So let's see, buns, right? How can 8 become 24? How many packages of 8 buns do you need? Yeah, you need 3 packages. So these questions, you gotta read them carefully because they're not asking for however many total, they're asking for packages, right? And hamburger patties, they are asking for how can 6 become 24? Right, 4 packages of patties. So you need to buy 1 more package of patties than buns so that you can make 24 hamburgers total. Right, because you want a hamburger with buns and you want a hamburger with a burger patty. Okay, so that's that. All right, thanks for watching. I hope this was able to help you. And okay, have a good one.
OMG, that was so good.